In the simple dryer example, we had a relatively modest change in water content between the incoming fresh air and the outgoing air. Is there any way to increase that change and thus be able to evaporate more water using the same amount of air? The simplest solution would be to heat up the air to a higher temperature before letting it into the dryer. This would, however, mean that we would need to heat up the drying goods to a higher temperature, which might be a problem, especially if the drying goods is heat sensitive. Another solution is to recirculate a fraction of the outgoing air from the dryer. We let the adiabatic dryer continue to work with a small change in water content, for example over here in the Molière diagram, but we create the incoming air to the dryer by mixing a fraction of the air with preheated fresh air and then heat that mixture. The fresh air usually needs to be heated to ensure that the mixing line stays within the Molière diagram. Because if any point on the mixing line has a relative humidity larger than 100%, there is a risk that water will condensate somewhere in the mixer. This since mixing might not be instant and perfect, and thus in some sections of the mixer, the mixing ratio might be different than the average mixing ratio. Condensation is usually wise to avoid, since condensation can lead to corrosion, and since condensation also may cause unexpected results, for example, fluctuations due to liquid water condensing and evaporating in the mixer. A clear advantage with air recirculation is that for a given maximum temperature, we get a much larger change in air-water content and thus need less air. Another advantage is that the increased airflow rates increases the turbulence, which in turn may increase the drying rate, which in turn means that we can build a shorter, smaller dryer. Let us draw an example in a Molière diagram. Fresh air with a temperature of 0 degrees Celsius and a relative humidity of 20% is preheated precisely such that condensation is avoided in the mixer. The preheated air is mixed with recirculated air and then heated to 55 degrees centigrade. The outgoing air from the adiabatic dryer has a wet temperature of 35 degrees and a relative humidity of 90%. The drying goods is heated to the wet temperature of the incoming air to the adiabatic dryer. Let us start by finding the outgoing air in the Molière diagram. The wet temperature line for 35 degrees is this line here. Note that there are help lines for wet temperature for 34, 33, etc. here below and there above. Please use this when you draw your graphical lines. If you draw a line with an incorrect slope, at least 1 point will be deducted on your exam. The outgoing air had a relative humidity of 90%, so G5 lies there. The air in the adiabatic dryer follows the adiabatic cooling line, that is essentially the wet temperature line. Thus G4 is the point where this wet temperature line intersects T equals 55 degrees. The air G3 is heated to give us G4, so G3 and G4 have the same water content. We draw a vertical line from G4. So far, however, we don't know where on this line G3 is. So let's start from the other end. The fresh air, G1, 0 degrees and 20% relative humidity is this point in the Molière diagram. The fresh air is heated in the preheater, thus we should draw a line straight up from G1, but so far we do not know where on this line G2 is. The final part of the puzzle is to realize what it means that the fresh air is preheated precisely such that condensation is avoided in the mixer. Condensation may appear if the mixing line at any point has a relative humidity higher than 100%. Thus, to avoid condensation precisely, we draw a line from G5 that is a tangent to the 100% relative humidity line and find G3 and G2 as the intersections of the mixing line and the vertical lines we drew earlier.